Okay. Well, good morning, everyone. I think we are now able to start. Welcome in our workshop. My name is Stéphane Sarad. I am director of the Program Energy Division in CEA, the French Atomic and Alternative Energy Commission. And this morning, with Jean-Michel Ruggieri, we wanted to share with you a discussion on how to go further with our nuclear power plant in order to produce more than electricity, but taking into account that in our French energetical transition, we will have to increase so much the amount of low carbon electricity in order to have a nice decarbonization of our use, transportation, and so on. So we will now show you a few slides showing up the concept that we intend to develop in CEA in terms of research and development. And after this small presentation with Jean-Michel, we will be very happy to share with you discussion about what do you think of those concepts and how to go further in this situation.
Yes, so I will present you the potential that we are seeing on SMR to provide cogeneration application and also to provide only heat application for nuclear. And you will see in the presentation, I will not focus on one type of reactor, not on PWR, on Gen 4 reactor, just giving to you the idea of how we go to study the systems. And then after that, we will look which type of reactor can be the best to provide the good heat for the chosen application. So what are the studies that we are doing on this innovative decarbonized nuclear energy system? And I insist, it's nuclear energy system, it's not only a reactor. So we are dealing with the first study case that we try to assess at CEA. It's how can we provide only hydrogen, decarbonized hydrogen with SMR. So it's quite easy. You say, okay, I have an electrolyzer, high temperature electrolyzer. I need to have heat, electricity, and I have this study case to address, to understand what is the best case to take which kind of SMR to have this application and to provide electricity at the price of the market. The second application can be only heat production, and for district heating, it's a type of, let's say, 100 or 120 degree of temperature. But if you go to industry, it can be almost the same. For some industry, it can be the same heat, but for other industry, it can be higher of temperature. It can go up to 600. The second application can be heat for the hydrogen, high temperature hydrogen, taking electricity from the network. It's another system. And you can go also to take this type of system with cogeneration with hydrogen, electricity, using hydrogen to store, let's say, the energy somewhere, and to provide some electricity with some pile to provide more electricity when needed for the network. So it's this type of let's say, study case that we want to assess with the nuclear. So at the end, the question that we try to address is which type of SMR for which type of, let's say, system, and for which type of market at the end. So that's why we have launched, let's say, a reading program with different axes. The first thing that we are looking at, it's SMR production, so the technology brick for SMR, hydrogen production with SMR. The second one is a technological brick, SMR for heat production, and you have a sketch of one of our SMR on our stand. There is also R&D on conversion energy system. You have seen that we need to look at the new energy system to provide flexibility to the system. And the first thing that we want to assess is the market studies to understand what will be the market of hydrogen heat for industry in 20 or 30 years from now. And all this is to address, finally, the decarbonization of the whole system and not only electricity. And for that, we have also launched a project with a lot of colleagues that are also here today, from VTT, from colleagues from France, EDF, colleagues from Italy, etc. We have launched these studies on the SMR to provide other things than electricity and to understand what will be, let's say, the type of system that I've seen to develop. What is the technical economy of this system? What will be, we are going to model the system, what will be the safety analysis of this type of hybrid system, and at the end to have a recommendation for stakeholders. So that will be the end. And the question is, okay, which type of SMR and system?
Thank you, Jean-Michel. So finally, our main motto is to say, in 2050, 9 billion people living on this planet, 60% living in urban areas, and therefore we'll have to produce for those territories, for example, either electricity, heat, hydrogen for mobility, and also, of course, potable water. And then that's this integrated view that we suggest to develop. So after this brief introduction, we wanted to share with you, and it's now open for discussion. The first one.
Yeah, I have two quick questions. So the first one, how far can we be from cities to produce urban heat, and at which temperature? What are the existing systems to transport heat? Because usually nuclear reactors cannot be really close to cities. And my second question is, have you looked at desalination? And also I've heard that nuclear could be used for carbon capture systems. So is it something...
So the whole question, the first one is what kind of, it depends of the reactor. If SMR, either high capacity one.
If you look at district heating, the new district heating network deal with almost, let's say, 19 degree Celsius for water. If you look at old network, it's 120, something like that. So it's the SMR could be a PWR one, but the size of the network. There is studies in France, and we have done studies for France and also for Finland and other country. And the size of the network is almost the needs is more 40 megawatt thermal. So it's very small reactor. So that's why we have done a lot of study to provide this type of reactor. And you understand that if the temperature for district heating network is 100 degree, the working point of the reactor is completely different. So we have developed a sketch of a reactor, PW1, but only with 10 bar in the primary circuit, with a 10 years life of the core batch, etc., to assess this type of application. And all the things that are put in this reactor is to be able to put the reactor near the application, and that's answer to the question how far it has to be from the need, and it's not that far, and I think it's not more than 80 kilometers of the application.
And you have to take into account another a possible application. It's to put such kind of reactor producing heat very close to heavy industrial areas as well. It's another option, and therefore you can be quite close to those industrial areas. Your second question was connected to desalination. Of course, desalination is interesting because the major process for desalination is reverse osmosis. And therefore, you have pumps, therefore you use electricity, and you need low carbon electricity. And the idea is for new process of desalination, if you had a small amount of temperature, 60, 80 degrees Celsius, therefore you increase the yield of separation. And that's one of the interests to couple desalination plant close to source of electricity and heat. That's the idea. For the carbon capture, we in CEA have other a much more long-term view, because the idea is to use nuclear power plant, and you will see mock-up in the CEA stand on that, on SMR, coupled with high temperature electrolysis. Therefore, you can produce hydrogen with low carbon. And then, if you're able to recover CO2 from industrial waste, either, and perhaps in the next future, from the atmosphere, you've got hydrogen, you've got CO2, and then, and you've got a large amount of low carbon electricity, and therefore we call that nuclear refinery. And CO2 and hydrogen, therefore you have methane, you have methanol, you have ethanol, you have ethylene, then polyethylene, you will have plastics. And the idea is to promote such kind of processes, not only to only recover CO2, because I think that it's much more interesting to transform CO2 into something instead of storing CO2. It's my simple point of view, and we can share that with you. But that's one of the answers. Another question?
When do you see the first market development for high temperature electrolysis? And why not also considering low temperature electrolysis systems? Is that 2030 or 2050?
For high temperature electrolysis, I think it's before 2030, because in CEA, with industrial partners such as Schlumberger, VNC, and Vencal, we created a joint venture last year. The name is Genvia. And the idea with the factory, which is in south of France, close to Béziers, and we are very proud because our president made the first inauguration last week of this plant. The idea is to produce a high-level quantity of stacks for that, and then the time to market for us will be in few years, before 2030.
A follow-up question then, what are the temperature requirements for high temperature electrolysis?
That's very interesting, because your question is very interesting, because it was the first beginning 6 years ago. Coming from nuclear activities, I was discussing with my colleagues working on high temperature electrolysis, and the temperature is roughly something about 500, 600. And my first idea, it was not possible to couple a PWR with that. And they explained to me that with the PWR, you can recover 150 degrees Celsius, and it's enough to start the reaction, because the high temperature electrolysis means an exothermal reaction. And therefore, with 150, you can switch on the light, and then that's why we had the idea to couple a few years ago. Another question, comments? No interest for those applications?
No, I can perhaps add some elements on direct air capture. Just that's why we have launched also an axis of R&D on conversion energy system, because the ratio between heat and electricity for high temperature electrolyzer is roughly 90% electricity, 10% of heat. And if you go to direct air capture, it's the reverse, so it's not the same. It's almost 60% of heat and 40% of electricity. So the conversion energy system is completely different, and we have to model it because it can have a lot of impact on the reactor transient. That's why we launched also the fourth axis to access also other study case.
Next question is concerning of thermolysis. What about it? What about high temperature reactors and thermolysis for the production of hydrogen?
For thermolysis, I think it's much more than it's something about 800, something like that. If you only want to make thermolysis, and then you can only achieve such kind of process with high temperature reactor, and then you can address directly thermo conversion. But our idea is to use all the knowledge and the technology that we have in PWR, ranging from a high-level plant to small and modular reactor, and therefore to use such kind of technology and quite intermediate temperature, 150, that can address high temperature electrolysis that it was mentioned previously, but also we can address district heating or industrial heating from some applications. That's the idea.
Yes, we can perhaps add that if there is a real need, I always say just developing SMR, advanced modular reactor with Gen 4 type reactor, it's not an objective just to do that. If you do that, you have to have needs for that, application for that. And for me, there is two types of application. Whether I need high temperature, and if you go to fast reactor, molten salt, you can reach almost 600, 650 degree for temperature of the outputs of the reactor. If you go to high temperature reactor, you can reach 700, 750, and then you have to go to very high temperature, and it's not completely achieved of that. But okay, if I need this type of temperature, it's interesting to develop a SMR on that. But I need to have a market for that. So there is a lot of study to do to be sure that I will address this market. And another use for that is not only the application of the heat, it's also the application of the reactor to the fuel cycle, to close the fuel cycle. So it's another story that we are looking at CEA. And that's why we say we use also, we can develop, and we are looking at development of this type of advanced modular reactor, also to close the fuel cycle and to have a sustainability of nuclear and a long-term nuclear development.
Yeah, it's very important because in fact we are working on two temporalities. The first one is if we want to decrease the time to market in order to achieve such kind of application, therefore our idea is to use SMR, which means PWR reactor, because we have the technology, we have the fuel cell, we have the fuel cycle, sorry. We have the fuel cycle in terms of fuel, of reprocessing and so on. So we think that the time to market will be quite short. And on the middle, long term, the idea is to develop advanced modular reactor, which are small, but for generation 4. And in this case, we open the range with all the concepts you explained, high temperature, molten salt, and so on. But for us, it's not the same, the same track in terms of time to market. We are both working on the two tracks, and in order to see how to combine, and then how to achieve a closed cycle of the fuel in the future.
So that's why all the sketches are not dedicated to one type of reactor. I don't know if Anice is there, but I have a lot of discussion with Anice from Tractable on that. And it's obviously we would like to look at all the application and then to provide a sketch on one application, one market, and just not to put a reactor because I want to have this type of reactor because it's beautiful. That's it. That's what we want to do.
Yeah, sure. Perhaps another question, another comment on that? Yes?
Don't you foresee a pressure from citizens in having a nuclear plant placed 80 kilometers away from their homes?
That's a $1 million question. In fact, that's the idea, that we have to work with that. And in fact, the question is, what is the main problem? Is it working, is it living close to a nuclear power plant in urban areas? Or is it the pressure given by the climate change and mainly the consequences of the climate change? And it's interesting because we can see a move on that. A move given by the young generation. For them, discussing for them, of course, they will have to face the consequences of the climate change. And with a lot of people working with Jean-Michel, we work on, we are teacher in some university and school, and we see the question is, okay, but are you able to design a reactor that we can build now? And then we can see that there is a move on the public. Everything is not done, and we have a lot of pedagogy on that. But I think one day the question will be not on nuclear. It will be on what kind of state of living do you want to achieve? And if we need energy, if we need much more electricity in order to decarbonize our habits, our industry, and so on. Therefore, that will be the question. So I don't have the answer of your question, but of course we are working on that. And I think that we have to make a lot of pedagogy of our activities, and mainly for the young generation, that we have to face this problem.
Just, I can add also in the Tandem project, there is an action specifically dedicated to understand the acceptance of the public of this type of dissemination of type of reactor near the population, to understand what is the thinking of the people, how does it change or not, and what can we do. And it's a good thing to do that in the European platform, because it's something that is interesting for everybody.
And if I may compliment to answer what my colleague has said, you have to look at Finland. In Finland, even the Green are promoting nuclear close to Helsinki, because they made a huge analysis, and all the parties, including the Greens, are promoting that. So it means that the public acceptance is okay. So for us in France, we really should look north, especially to Finland. So it exists, in fact. It just has a promotion, as Stefan has said.
Yes, in northern country of Europe, we have such kind of application. And we can also add what we saw in China. In China, the way to put a small and modular reactor very close to urban areas, close to Shanghai, for instance, they are ready for that. And they are asking us to help them to develop as quick as possible.
Oui, je voulais dire qu'il y a une ville en Chine dont je ne me rappelle plus le nom, c'est des AP1000, hein, et ils sont sur plusieurs millions de homes, enfin de foyers. Et un point aussi qui est très important par rapport à la Chine, c'est qu'aujourd'hui, ces réseaux de chaleur existent et ils sont à 95% charbon. Quand on se balade dans les grandes villes chinoises, on voit ces petits réseaux de quartiers avec des petites centrales à charbon, enfin c'est pas des centrales, les chaudières à charbon dans le quartier, donc c'est extrêmement polluant. Donc un des premiers bénéfices évidemment dans ces environnements, c'est la propreté de l'air en fait, qui est un bénéfice énorme que peuvent apporter les petits réacteurs nucléaires. Mais je pense qu'il faudra vraiment qu'on travaille sur le modèle de sûreté, modèle enterré, enfin tous ces modèles-là qui peuvent en effet rassurer les gens. Et puis bien sûr, il y a de nombreux échangeurs qui sont là pour aussi rassurer les gens sur la qualité de l'eau qui va dans les radiateurs.
The main keywords are safety, security, and of course techno-economical trends, because those projects must meet the reality of the price of temperature and electricity.
No, just to conclude, it's what guides the setup of this European project. It was a lot of discussion to assess that, and there is almost all the things, even if it's not very deep studies. It's only 3 years, there is a lot of people in the project, but we would like to assess all these items: safety, acceptance of the public, the market, technology, to be sure that we have a first sketch that is something understandable for the industrial, for the stakeholders, for the government policy, etc.
I think we have to conclude. Okay, thank you so much for attending this workshop. Thank you. With Jean-Michel, today we are there, so we are ready to answer any question. And of course, you are warmly welcome in the CEA stand, which is just behind you, for visiting and have more information. Thank you so much, and enjoy your visit in WNE.